everybody, it's Dr. Nigro here with the screencast for our notes. This screencast is going to cover notes for collisions and specifically a recoil collision. All right, before we can get to recoil, we should do a little bit of background. The first is going to be a definition of collision. All right, now most people have used that word. In physics, we tend to have a very specific definition of collision, and so a collision is a short duration, and that's important. All right, it's not going to be very long, but it will be an interaction between two or more. It doesn't have to be just two. I mean, we could have three, we could have four objects. All right, but these objects are going to interact. All right, and that interaction cannot be very long. It's going to be short. All right, now there are a lot of examples out there of collisions. I'm sure you could come up with two of your own. All right, but I have to admit that whenever I hear the word collision, the first thing I think about are cars. All right, so car accidents, definitely considered collisions. All right, but you see collisions in sports a lot. It could be between two players on the field, or it could be, let's just say, when a hockey stick hits a puck. All right, that would be a great example. All right, you could also say when a baseball bat hits a baseball, maybe when a soccer player uses their head and hits the soccer ball. All right, all of those are very short durations, and it is an interaction between two or more objects. So those are all considered collisions. All right, now when two objects collide, they do bring their own momentum into that collision. And remember, a momentum, which is P, is equal to the mass of that object times its velocity. And we're going to find that as the mass and velocities vary between the objects, that really impacts that collision. All right, so let's think about it in the terms of two football players. I've got two here. I've labeled them A and B, and they're going to collide on the field. Now, there are really three different scenarios that could occur because of this collision. All right, the first one, maybe player A ends up pushing player B backwards. All right, so they collide and player A continues forward and player B gets pushed backwards. All right, the opposite could happen. Maybe player B collides with player A and pushes player A backwards. All right, and then finally, what could happen is that when they collide, A and B come to a stop. All right, now, which of these scenarios actually happens is going to have a lot to do with the momentum of the players as they come into that collision. All right, so we're going to be talking a lot about momentum. Now, regardless of what happens, the result of the collision, all right, the total momentum before that collision, so the momentum of player A and the momentum of player B, must be equal to the total momentum after that collision. All right, and whenever we have a variable that has to be the same before and after, all right, we say that that has to be conserved. So in other words, momentum must be conserved. All right. All right, so let's get into collisions specifically. All right, there are three types of collisions that we're going to deal with. The first is called recoil, and we're going to define each one of these separately. All right, the second one is inelastic, and then the third one is elastic. All right, we're going to learn how to recognize based on a description of a collision which type it is, and then we're going to learn how to show that that momentum is conserved and how to find unknowns in these different scenarios. All right, now when you're working recoil, inelastic, or elastic problems, you should always draw a diagram of what's going on. All right, we want to show the objects before the collision and then after. All right, and some of the information that is good to include in that diagram is direction of travel, velocity, and mass values. If you have them, you don't always have them, but if you do, it's good to label. All right, remember when we're talking about direction, velocity sign is going to be our hint as to what is going on. Now, there might also be words within the description, like to the left or to the right, which also is going to help us. But the sign also is going to be important because that sign for velocity indicates direction. And we are just going to define left as negative. All right, so if your velocity value is negative, that means that object is moving to the left. All right, and we'll keep right as positive. All right, so if your velocity value is positive, then that object is moving to the right. So by keeping that in mind, it's going to help us all stay on the same page. All right, now, no matter what type of collision, remember the total momentum before must be equal to the total momentum after, because momentum must be conserved. All right, now I realize we just wrote that a second ago, but it is one of the most important parts of this entire unit. So we need to write it and remember it. All right, so we're going to move on and look just at a recoil collision. All right, now a recoil collision has a very specific set of circumstances that vary from elastic and inelastic. All right, so a recoil collision occurs, all right, when you have two objects. I guess you could have more than two, but we're just going to deal with two. All right, when two objects are moving together or at rest together. All right, the key is together. This is the important word. All right, and then they move apart. All right, we use the word explode away from each other. And what that means is that they move in opposite directions. All right, now this word explode, I want to come back to this because students always get very excited because they think all of a sudden we're going to do explosions, but we are not. The word explode just means a very quick movement away from each other. All right. Now, we are asked for an example here. All right. So if we wanted to give one example of a recoil collision, I think one of the best ones is a baseball pitch machine. Whoops. And a baseball. All right. Initially, the two are together. The baseball is inside the pitch machine, and then the pitch machine shoots the baseball out. Now, you may not think that the pitch machine is moving, but it actually does slide back just a little bit because of the recoil between that interaction between the baseball and the pitch machine. All right. Now, when we deal with these different types of collisions, we tend to do so by looking at cars or carts on a frictionless track. All right, so we're going to use this as an example. So here's our situation. We have two carts, A and B, that are sitting on a frictionless track, motionless. Each cart has a mass of 1 kilogram. Suddenly, the two carts explode away from each other, moving in opposite directions, each with a velocity of 2 meters per second. And then the question is, was momentum conserved in this collision? All right, so let's start with our diagram. All right, so I've got cart A. Whoops. All right, give him some wheels. All right, and then right next to cart A, I have cart B. And there is no motion. They are not moving. All right, now after the collision, it tells me that cart A is moving away from cart B, and that each have a velocity of 2 meters per second. All right, so our picture before, slide this guy over a little bit, has the two carts not moving right next to each other, and then after the collision, the explosion, they're moving in opposite directions away from each other. So this is what a diagram would look like for this collision. All right, now we want to calculate momentum values, and we're going to start by looking at before the collision. So we'll look at cart A. So cart A has a mass of 1 kilogram, right? And it's at rest before, so it has a velocity of 0. All right, so to calculate momentum, It's mass times velocity. So in this case, 1 kilogram times 0 is going to be 0. So the momentum of cart A before the collision is 0. All right, we move to cart B before the collision. So 1 kilogram, and it had a velocity of 0. All right, so the momentum for cart B is going to be, again, mass times velocity. So 1 kilogram times 0 is going to be equal to 0. All right, so we have our momentum values for our two carts before the collision. All right, now we're going to look at the momentum of the two carts after the collision. All right, so for cart A, we again have a mass of 1 kilogram, and it's moving at 2 meters per second, but to the left. So we give it a negative sign, and then we calculate the momentum for cart A after. It's again mass times velocity, so 1 kilogram, but this time times a negative 2 meters per second. So our momentum is going to be negative 2 kilograms times meters per second. Remember, that is our unit for momentum. All right. We then look at cart B, also 1 kilogram, with a velocity of 2 meters per second, and it's moving to the right, so it's positive. So our momentum for B after the collision, mass times velocity, 1 kilogram times a positive 2 meters per second, gives us a momentum value of a positive 2 kilograms times meters per second. All right, so 2 kilograms meters per second. All right, so to look at conservation of momentum, remember the momentum before has to equal the momentum after. So we need to find these momentum values. All right, so if we go back and look at our values for cart A before the collision, we had a momentum of 0, and for cart B, we had a momentum of 0. After the collision, for cart A, we had a momentum of negative 2 kilograms meters per second, and for cart B, a positive 2 kilograms meters per second. So if we add the two sides, we get a 0 for the before, and then negative 2 plus positive 2 is also 0. So does the before equal the after? You would have to say yes. All right, so was momentum conserved? And the answer here is yes. And the explain part is the momentum before the collision equals the momentum after. All right, so as long as the momentum before and the momentum after are equal to each other, then you would say that momentum is conserved. Okay? All right, so that's just our intro into recoil. Let me know if you have any questions.